this device is specially trimmed for low power. It only consumes 700 microamps, which is quite low for a sensor that is being heated up to 300 degrees Celsius.
Hi, it's Eamon with ipXchange. We're on the ScioSense booth at Sensor+TEST, which I don't actually know if we're meant to be in at the moment, but we are. I'm here talking with Rolf about some of their latest sensors. So, Rolf, what can you tell me about ScioSense's latest devices?
Yeah, what we recently launched is the ENS161. It's a VOC sensor. It's a low power version of a VOC sensor, which has a significant advantage compared to let's say, other typical VOC sensors. There's an ASIC introduced in the VOC sensor as such. Okay. So underneath the hood of this very small 3 by 3 millimeter device, you have an ASIC that does all the data processing, with the big advantage that you do not need to put any libraries or anything on your master MCU, and can let's say, obtain all the data and all the signals out of the device. What kind of signals are these?
Okay.
It's ECO2, it's an equivalent CO2, which is a very common signal that is being used in the air quality world. The other one is TVOC, total VOC. Then we have various air quality indices that you can also obtain from the device.
Cool. So that sounds like it drastically reduces the possible size of your end device, because you don't need the processing externally.
Absolutely, cool. Exactly, and also reduces the processing power that is required. So you might let's say, end up with a smaller MCU.
Oh, excellent. Yeah. So if a design engineer wanted to introduce this into their technology, into their device, is this an evaluation board that they can use, or?
Exactly, that's an EVK we are using.
Okay.
So it also has a temperature and humidity sensor on board.
Nice.
for humidity compensation if that is required.
Not
really required, but if customers want to have that, well, this can be provided by us as well.
Excellent.
It's actually our own component. It's the ENS21X family.
Oh, nice.
Yeah.
Cool. So in terms of general applications, I can see that there's IoT devices and wearables and home applications. What kind of things have your customers put them in so far? Or I guess it's so new that maybe they haven't, but what would you envisioning them putting them in?
First of all, low power applications. That is important, because this device is specially trimmed for low power.
Okay.
It only consumes 700 microamps, which is quite low for a sensor that is being heated up to 300 degrees Celsius. And that's the one thing. Then IoT devices that are battery operated, and even wearables.
Okay. So you said heated up to 300 degrees Celsius. So what's the max temperature range of this device? That's a wide range.
Well, this is a bit dependent on what you want to measure.
Okay.
So we are measuring oxidizing and reducing gases.
Okay.
So reducing gases are, for instance, the ones that are combustible, like smells and so on, hydrocarbons, etc. So let's say from skin respiration and so on from human beings.
Cool.
That you measure in the room air. And this is the one thing. There the temperature is around 300 degrees Celsius. And then we're also looking for oxidizing gases, like for instance ozone or NOx or something, which is in the range of 250 degrees Celsius.
So that was the first of, I think, 4 different demos we did on the ScioSense booth. Very, very interesting technology, fantastic practical demos. So learn more about the ENS16X devices on the ipXchange website, and look forward to the next demonstration. Take care.